Hello everyone. Today we're going to be talking about multivariable equations, or they're also called literal equations. So what I need you to do is just as normal, go to the Dropbox, get the notes, print them out, do whatever you have to do in order to be able to take notes along with me. In order to receive full credit for this video, what you need to do is send me a picture of your completed notes on Google Classroom. And you'll have homework associated with this. It looks like you will have, looks like next week you should have another quiz. It should be quiz 2-2. Hopefully we can work towards that. So if you have any questions during this video, please let me know. Message me on live grades or text me. Please do not leave a private comment on the Google Classroom. Other than that, let's get started. So today we're going to be talking about literal equations or multivariable equations. So just to help you remember that, we're going to write under the notes and examples. It's equations that have multiple variables. All right, and remember that variables are usually the letters, so like A, B, C, D, E, F, G, all the way through Z, whatever you want to do. So what we're going to do to begin this is we're going to solve an equation. So we're going to be solving the 2x minus 5 equals 13, and we're going to try and figure out what x is. So by now we should be in the habit of just knowing exactly what to do whenever we look at it. So first step, we're going to add 5 to both sides. When we do that, these 5's cancel. We're left with 2x is equal to 13 plus 5 is 18. And then once we get to this point, what we have to do is divide by 2 on both sides again. So that means that x is equal to 18 divided by 2, which is 9. So after that, that's it. All right, so that's the answer. X is equal to 9. But instead of just having letters and numbers, what if we just had letters? So if we look at the example to the right, we have ax minus b is equal to c. Now, there are no numbers, but I still want you to solve for x. And we can do that without any issues. So what we have to do is we have to add b to both sides. Just like we would in any other thing. If we have a negative b and we're adding a b, it goes to 0. So we're left with a times x is equal to c plus b. And we're trying to solve for we're trying to solve for x, so we have to get rid of the a. Since the a is being multiplied, what we need to do is divide by a on both sides. The a's cancel, and we're left with x is equal to c plus b over a. And that's all you have to do. So it's just trying to work with the numbers or work with the letters like you would with numbers so that you're able to reduce it or solve for any variable that I tell you to. So I could ask you to solve for b instead of x or a instead of x. And your goal would be to isolate the a or isolate the b, whichever one. So what I want you to do is take a few moments, pause the video, and try and think of some similarities and differences between the two equations above. So what did we do to solve the equation on the left, and what did we do to solve the equation on the right? How are they similar? How are they different? Alright, so you should have thought of some. We could say that both of them use opposite operations to isolate. And maybe instead of opposite operations, you could change that to inverse operations, because that's the better mathy term. All right? And then the difference would be the equation on the left, so the left equation simplifies to a nice number, while the right equation does not. It's ugly. So I'm just going to say right equation is ugly. All right? So, and it's ugly because there's so many different variables. It's just not a number. So what we're going to do is we're going to be working with just letters for this lesson. And we might be working with just letters for a little bit so that you get the idea of what we're actually having to do whenever we solve equations. So let's go down to the one-step problems and look at number 1. We have A is equal to L times W. In other words, this is the equation for area of a rectangle or some sort of shape like that. We have that the area is equal to the length times the width. And we're asked to solve for W. In other words, we're trying to figure out what the width is. So in order to do that, what letter do we have to get rid of? In this case, it would be L, because we need to isolate W. So we have to divide by L on both sides. This L cancels with this L. We're left with A divided by L is equal to W. And since W is isolated, we solved for it. So this would be our answer. All right? I want you to try 2 by yourself. Remember that for 2, you're trying to solve for H. Number 3, we have D is equal to R times T. Okay? We're asked to solve for T. So what letter do we need to isolate? T. Okay, so we're on the left side, or the right side of the equal sign. Now, which letter do I need to get rid of? R. It's being multiplied, so I need to divide. So I have D over R is equal to, the R's cancel, we're left with T. So T is isolated and we've solved for it. This is our answer. Number 4, I equals PRT. We're asked to solve for T again. Okay? So we figure out what side T is on. It's on this side. Now we have to get rid of the P and the R. So we can actually divide by P times R. The P and the R's cancel. We're left with I over P R is equal to T. Since T is isolated, we're done. Okay? Number 5. V is equal to L times W times H. We're asked to solve for H. So, looking at this side, we have to get rid of the L and the W. So we have to divide by both. Whatever we do on one side, we have to do on the other. These cancel. We're left with V over L times W is equal to H. Since H is isolated, we have that this is our final answer. All right, number 6. We have A is equal to pi r squared. We're asked to solve for r. So what we have to do, first off, is get rid of pi. So we have to divide by pi. The pi's cancel. We're left with A over pi is equal to r squared. But we're not finished because we have to get r instead of r squared. So we have to get rid of the squared. In order to do that, we have to take the square root of both sides. When that happens, the square root cancels with the square. We're left with r is equal to plus or minus the square root of a over pi. This plus or minus is important because whenever you take a square root, you get two options. You either have a positive number or a negative number. So it's better to say, well, here's both of the numbers instead of just one. All right? So since r is isolated, we have that this is our final answer. Let's look at number 7. M is equal to C minus S, and we're asked to solve for C. So in order to do this, we have to get rid of the S. It's being subtracted, so we have to add it. So we have M plus S is equal to C. C is isolated. We're done. Finally, for number 8, we have D is equal to M over V, and we're asked to solve for M. So, in order to do this, we have to get rid of the V. Since the V is on bottom, we can multiply by V on both sides. That means V times D is equal to M, because the V's cancel. M is what we were solving for, and it's isolated, so therefore that's our final answer. Let's move on to the second page. Alright, so on this page we have multi-step problems, so meaning that we're going to have more than one step, of course. And whenever we're solving these, we have to basically think PEMDAS backwards, so please excuse my dear Aunt Sally. We're going to have to think of it backwards, so Sally, Aunt, dear, my, excuse, please. Yeah, makes sense. So we're going to have to think of that. Then we're going to have to remove fractions by multiplying by the reciprocal. Remember that a reciprocal of a fraction is just whenever you flip it. And the last step is usually to divide by whatever is next to your variable. So whether it be 2, 5, 13, whatever, you're going to divide by that so that you go ahead and finish off whatever you have. So let's look at number 9. We have A is equal to 1/2 times base, or 1/2 times B times H. We're asked to solve for H. So that means we have to get rid of the 1/2 and we have to get rid of the B. So let's do this one step at a time. Our goal is to get rid of the 1/2 first. So since it's a fraction, we're going to be multiplying by its reciprocal, and the reciprocal of 1/2 is 2 over 1. We're going to multiply that on both sides. So left side simplifies to 2a is equal to 1 on bottom, 1 on top, 2 on bottom, 2 on top. So we're left with BH. And remember that we're solving for H, so now we have to get rid of the B. So that means we divide by B on both sides. We now have 2a over B is equal to H. H is isolated, and therefore this is our final answer. Try number 10 by yourself. Remember that you're solving for capital B. Let's look at number 11. We have K is equal to mv squared over 2. We're asked to solve for m. First step, we have to get rid of this 2. Since it's being divided, we multiply. So we now have 2k is equal to mv squared. And we're solving for m, so that means we have to get rid of the v squared. Since it's being multiplied, we can divide. So we have 2k over v squared. These cancel. We're left with m. Since m was what we're looking for, and it's isolated, we're done. Alright, for number 12, we have a is equal to b plus c over d. And we want to solve for b. So we're looking for this guy. So we have to get rid of d and c. First, we have to get rid of d since it's on bottom. So in order to do that, we have to multiply by d on both sides. So we now have dA is equal to b plus c. Since we're solving for b, we have to get rid of c now. So the way we're going to do that is subtracting c from both sides. We have dA minus c is equal to b. Since b is what we're looking for and it's isolated, it's our final answer. Alright, let's look at P. 13. 13 says P is equal to 2L plus 2W. In order to solve this one, we're having to solve for W. So let's try this. Alright, so we have P is equal to 2L plus 2W. We're solving for W. So the first thing we have to get rid of is this 2L. So we have to subtract 2L from both sides. We now have P minus 2L is equal to 2W. And since we're looking for W, we have to get rid of the 2. So that means we have to divide by 2 on both sides. So we're left with P minus 2L over 2 is equal to W. Since W is what we're looking for and it's isolated, that's our final answer. All right, let's look at number 14. We have ax plus by is equal to c, and we're asked to solve for y. So, first step, we have to isolate y. So we have to subtract ax from both sides. So we have by is equal to c minus ax. Next we have to get rid of the b, because that's the thing that's next to the y. So we're dividing by b on both sides. The b's cancel. We're left with y is equal to c minus ax over b. And since y was what we were solving for and it's isolated, this is our final answer. Okay, number 15, y equals mx plus b. We're asked to solve for x. So what we have to do is get rid of this b first. So we're going to subtract b on both sides. We have y minus b is equal to mx. We're solving for x, so we have to get rid of the m. Since this is being multiplied, to get rid of it, we divide. So we have y minus b over m is equal to x. And that's going to be our final answer. Number 16. We have a is equal to p plus prt. We're asked to solve for t. So what we have to do is start solving this equation for t. We have to isolate it. So that means we have to get rid of the two p's and the r. So we have to subtract p first. So we have a minus p is equal to prt. Now we're having to get rid of the p and the r, so we're having to divide. Those cancel. Do it on both sides. So we're left with a minus p over pr is equal to t. Since t is what we were solving for and it's isolated, this is our final answer. Number 17, we have c is equal to 5 over 9 times f minus 32. So what we have to do is to solve for f. So let's start. In order to do this one, we have to get rid of this fraction. And in order to get rid of a fraction, you multiply by the reciprocal. So in other words, we're going to multiply both sides by 9 over 5. All right, 5 on top, 5 on bottom, 9 on bottom, 9 on top. We're left with 9 over 5. C is equal to f minus 32. Now we're solving for f, so we have to get rid of the negative 32. So we're going to add 32 to both sides. So we have 9 over 5. C plus 32 is equal to f. Since f is what we're looking for, and it was isolated, therefore it's our final answer. Finally, number 18, we have a is equal to 1/2 times h multiplied by b1 plus b2, and we're asked to solve for b1. So, first step is to get rid of the fraction, so we're going to multiply by the reciprocal. We're left with 2a is equal to 1 on top, 1 on bottom, 2 on bottom, 2 on top. H times b1 plus b2. Okay. We have to work inside of the parentheses, so we have to get rid of this h. So that means we have to divide by h. Those cancel. We're left with 2a over h is equal to b1 plus b2. We're asked to solve for b1, so that means we have to subtract b2 from both sides. So we have 2a over h minus b2 is equal to b1. Since b1 was what we're looking for, and we have it isolated, this is our final answer. And that is it for the notes. If you have any questions, please let me know. Make sure that you have number 10 as well as number 2 finished whenever you turn this work in. If you have any questions, please message me on LiveGrades or text me. Remember, do not make a private comment on the Google, on the Dropbox, because I'm not able to see it until I start grading. If you need any help, please let me know, and I hope you have a wonderful day.